Hi, I'm Anders Hejlsberg. I've been at Microsoft since 1996. I'm a technical fellow in the developer division, and I work on programming languages and software development tools. And I have pretty much done that for my entire career, which now spans a little over 40 years. I was born in a suburb of Copenhagen in Denmark, just north of Copenhagen. And grew up there. I was fortunate enough, was one of the first schools in Denmark to offer the students access to a computer, which I think must have been back in, for me, probably 76, 77, the first time we got to lay our hands on an actual computer and we got to program it. And I often joke that for the first 2 weeks, the teachers would teach us how the computer worked. And then for the remaining time, we would teach them how it worked, because we just got in there and like tried everything, programmed it in machine code, like wrote bootloaders, like tortured the hard disk drive and the paper puncher. We wrote programs that would like do ticker tapes and all sorts of stuff, right? We knew that thing inside out. Okay, what was it about the first computer that sparked my imagination? I don't really know why. I mean, I think there's something very appealing about the little world you have in a computer where you get to control everything, right? And there's something very satisfying about implementing something complicated and then seeing it work, or understanding why it didn't work and then figuring out how to make it work. It's just, I don't know, it's very addictive. At least to me it is. I decided to work in computers because at heart, I'm an engineer, and engineering was always something that was in the blood of my family as well. My dad was an engineer, and so I knew pretty early on that that's where I wanted to go. These machines back then typically all came with Microsoft's ROM BASIC in them, and that included the one in particular that I was interested in was a British kit computer, a Z80 based kit computer called NASCOM, and it had Microsoft's 8K ROM BASIC in a ROM on the motherboard, and of course you start out writing in BASIC, but BASIC is not, that's not for real programmers, right? I mean, it's too slow. It's not quite. It lacks stuff, but it's not close enough to the metal, right? And so I pretty quickly got interested in how do you write really efficient code on these machines? And that meant writing in assembly code or in machine code. And so I started writing a bunch of different software after I had written games in BASIC and sort of gotten tired of that. Started writing assemblers and disassemblers and on-screen editors, and wrote a small operating system. Floppy disk drives were just becoming available. Before that, it was like cassette tape. But I also got interested in this programming language called Pascal. And then I wrote a small compiler for the Pascal language after first teaching myself how to write compilers. And it was all written in assembly code and machine code, because that was the only way you could squeeze it on a machine that at most could have 48K of RAM, because some of the address space was taken up by that Microsoft ROM BASIC and other things, right? And eventually that ended up being a 12K Pascal compiler and runtime and on-screen editor. At Polydata, we had built what is basically the predecessor of Turbo Pascal. We had a project called Poly Pascal, it was called, which was our basically version of Turbo Pascal. It had a compiler, a runtime library, an on-screen editor. And one of my co-workers knew this other Danish company that wanted to get into software. They had founded this company called Borland. They had a couple of products written already in Pascal. My buddy explained to them how, we have actually this Pascal development environment that is way better than that. You really should give it a shot and check it out, and gave them a copy of it. And within a week, they came back and they were just floored, and suggested that we do a deal where we jointly take our product and change it around and make it into what became Turbo Pascal. And that's basically how we started. And this company I worked with, the three founders, Niels, Mogens, and Ole, all Danish. And they had a few other programmers, and they were in Copenhagen, and we worked together that was in 83, for about 6 months to repurpose our product and then launch it as Turbo Pascal in the US. So I moved to the US to be closer to the action. And then was with Borland in the US from 87 until 96. And built a long succession of versions of Turbo Pascal. I think we got up to Turbo Pascal version 6 or 7. And then we built the successor to Turbo Pascal called Delphi. So there were a lot of Borland people at Microsoft, including, say, Brad Silverberg, for example, who had been VP of R&D at Microsoft, at Borland. And he would call every summer, and I wasn't ready. And then in 95, I was sort of maybe I'll come up. And so next summer in 96, I finally decided, okay, it was time. Microsoft was going to be a juggernaut, right? And it was way bigger at the time than Borland. And to have a company to get in on that would be incredibly exciting, right? I remember interviewing with Paul Moritz. When I first started, I'm trying to think who I ended up reporting to, Yuval Neiman, I think, who was running DevTools at the time. And my immediate manager was Brad Lovering, who was in charge of, believe it or not, Visual Basic 6.0. But I was brought on board at the time ostensibly to be the architect of Microsoft's Java development tools. And this was sort of commensurate with the internet all of a sudden, like taking over the world, right? And oh my God, here was a language made for the internet. At least that's how it was framed, right? And you could write applets, in your web pages, and it was like this compile to bytecode, write once, run everywhere, object oriented. Oh my God, it's like it checked all the boxes. And right when I came in, it was, I think, Visual J++ 1.0, which was really just sort of like a product where we took the C++ compiler out and put in a Java compiler instead. But then we set off to build Visual J++ 6.0, which was going to be the first rapid application integrated development environment for Java. And that was a lot of fun to work on. And we built a really cool product, except then the whole lawsuit between Sun and Microsoft happened. And our product got enjoined literally by a judge in San Jose that forced us to put up warning dialogues. You are about to use Microsoft proprietary extensions. Do you wish to proceed? Yes, no. And at that point, it became clear to ourselves and the leadership that it probably wasn't the wisest decision to base your core business on a product that you've licensed from somewhere else. We needed to build something where we could control our own destiny and deliver the best possible solution to our customers, right? And that was, I think, the genesis of .NET. This idea of building a runtime that could compete with Java, but at the same time offer seamless interoperability with all the technologies that already existed in Windows, like COM and Olay and what have you, like the way that apps were built to interoperate before we had the .NET runtime. And of course, we needed a programming language on this platform. And one of them was going to be, we were going to build we called it the Common Language Runtime, or the CLR, because we knew from day one we wanted to support the ability to run multiple different programming languages on the same platform. And one of these programming languages, of course, was going to be Visual Basic. And the other was going to be C++. But we also full well knew that what people really wanted was the ease of use of Visual Basic with the power and expressiveness of C++. in a sense. That was because we saw people write apps in Visual Basic. And then once they were happy with the prototype they wrote in Visual Basic, then they translated it into C++, which meant you wrote the app twice and you had two teams, and it was very costly way of doing it. What if we could create a language that really could span that spectrum, right? And that was what motivated us with C#. And that was sort of the marching orders, if you will. We need a language like that. I was lucky enough to be given the task of building this language. I remember writing a 4-page white paper called "What is Cool?" because that was the name of the little prototype language that we were in the process of building. It stood for C-like object-oriented language, and we had all our file extensions were .cool. It was very cool, and it basically laid out this. A blueprint for this language that would give you the power of C++ with the ease of use of Visual Basic built on top of the .NET runtime, or the yet to be named .NET runtime. At the time, I was working with Scott Wiltermuth, became the product manager, and we pretty quickly formed a design team of about six to seven people. It was sort of rotated. Some people would leave, other people, and then we'd find replacements, put them in. But from the get-go, we had 2 design meetings a week, each of 2 hours. We took copious notes we had 3 design meetings, sorry, Monday, Wednesday, Friday. We took copious notes and basically built a spec for the language whilst in parallel implementing the first compiler for the language. The compiler team was headed by Peter Goldie. And we wrote that first compiler in C++, or rather C++. We didn't use all the features of C++, but because we didn't have the language, we couldn't write it in itself. So we weren't bootstrapping yet. So we were writing the compiler in C++ as we were evolving the spec. And that probably took from get-go until the first workable implementation, 12 months, maybe 18 months. We had the first working language. Where you could actually write apps, and there was a language spec that specified exactly how it works, so people could learn from and how you're supposed to construct the programs and so forth. There was, of course, a big effort at the same time to build the .NET framework, all the libraries that come along with the framework, which effectively is the runtime for that language, right? Well, creating a new language is like an opportunity that rarely comes along. And I often joke, the world needs another language like it needs another hole in the head, right? I mean, no one needs a new language because that means everything starts from scratch. Yet, new languages are the way whereby we make progress. The first preview of .NET was released in the PDC in the Professional Developer Conference. And I remember being on stage with John Shuchuk and presenting, our vision for .NET. And at the time, XML was the buzzword also. The world was sort of moving from, first we'd sort of gotten to the internet age, right? Where it was humans using browsers to talk to computers somewhere else, right? Through the browser. But the newfangled idea was computer-to-computer interaction over the internet, right? The ability to do REST services and remote calls powered by the internet for computers to speak to each other, right? Over the same infrastructure that we used for browsing, so basically over the HTTP infrastructure. And XML was the new thing for that. And so .NET was sort of branded as the native for XML REST services runtime at that time of release, even though that wasn't necessarily what we had built it for, but sure, it worked well for that. And I remember doing a lot of presentations about all of that infrastructure, and this is when ASP.NET, became our web server, right, for .NET, and where we dramatically changed how easy it is to build websites and to build services, REST services. That, I think, was a big change. That was really not a thing that existed before. And so that all of a sudden furthered a whole new kind of app that you could build. These back-end cloud services. That was the beginning of that, right? I think, I would like to say that the thing that's always driven us in the developer division is like making programmers more productive, making it easier to build apps that have real world impact, right? And I think for ordinary people, like this advent of markup, HTML markup, and the ability to put code behind it and build your own websites, and literally like build your own e-commerce, or I mean, it completely changed the world. And it was the early days of the way the world looks now, where that's all we do, right? I mean, now our PC, well, they're our personal computing device is the phone now, in a sense, right? And we walk around with connectivity at all times, the ability to interact with computers and systems everywhere in real time, like do commerce, do social interactions, do email, do video, entertainment. It's all powered by backends that are built using the kinds of tools that we were launching at that time, right? What was next was making it successful, right? I mean, because the first 1.0 of a product can be fantastic, but it is also full of things that you didn't get to, right? And so we had a long list of things that we knew we wanted to do to mature the language, right? And I've always been a believer in playing the long game, in sticking with a project, not just for one release and then moving on to something else, right? Development tools are different. Like I stuck with Pascal and Turbo Pascal for a decade, and Delphi for, like an overlapping decade, right? C# I was with for over a decade, right? And you kind of have to, in order to truly make great products. They don't, it's just not possible to have a perfect programming language and development environment surface out of thin air in one release, right? After you've done something for 10 years, it's you get a certain itch, that an urge to maybe try something different. And all of a sudden, there's this platform inside the browser that allows you to build real apps with a completely friction-free deployment model that runs everywhere, including on mobile devices and iPads and whatever. And of course, everyone was sort of getting wind of that. And they were going, we need to write apps that run in the browser. The browser is the new application platform, right? Except JavaScript is a horrible programming language. It's a dynamic language. It harkens back to, in a sense, the same principles as these early basic interpreted languages, right? It's very hard to build good tools for JavaScript because JavaScript lacks some of the fundamentals of more modern programming languages like Java or C+ or C#. It lacks a static type system. And static type systems are what allow programmers to express their intent with the program. They don't just create a variable called X, and then you can put anything you want into X. You can put strings or numbers or lists or objects or no. In grown-up programming languages, you not only say I want an X, and I want X to be a number. And I want you to assume, and I want you to tell me if I ever make a mistake in not putting numbers into X or whatever. And I want to be able to describe to you what my data structures are supposed to look like so you can validate that they actually look like that and catch the errors before I run the program. It's better to find the errors before the space shuttle flies than whilst it's flying, right? And so compiled languages were super important in the enterprise, yet on the front end, all you had was JavaScript, which is interpreted and does not have a static type system. And so we set out to understand what is it that's wrong with JavaScript and how can we make it better? And how can we build this development experience that these people are expressing to us that they desire, but that they don't have. And therefore they're doing this other thing, right? And that was what became TypeScript. Our first official release was in October of 2012. But the core early founding team, myself, Steve Luco, and Luke Hoband, we were probably doing. We started in December of 2010 to come up with the initial ideas for what is this going to look like, and what is it that we're going to try and build. Well, what I'm most proud of with my time at Microsoft is that I got to participate in the creation of 2 of the world's 5 most popular programming languages today, and that I have millions of programmers use these tools every day to build software that powers the world, and that is just immensely satisfying. It just makes you feel like the work you do is relevant, and we all want to be relevant. We all want to do stuff that the world cares about, right? I mean, that is ultimately the thing that gets you going. At least to me, it is. So that's probably it. You know, like knowing that you've made a difference, you know, in your work, right?